Welcome everyone. I'm really excited to kick off CNS Summit 2020 with a live in-person interview with Bryan Johnson, CEO of Kernel. As you know, CNS Summit is well known for introducing leaders and companies you've never heard of before, but you will be hearing of in the future, and this is definitely the case today. I'm excited to be here at this building, which I've been to before, but till recently was an undisclosed location. So I'm very pleased to be here with Bryan to have this interview. So Bryan, thank you for welcoming us into your office.
Welcome.
Could you please tell us about your background, where you grew up, and how did you end up being here today?
So I grew up in a small town in Utah,
A
deeply religious community, and growing up there led me on the path to serve a 2-year mission as a missionary in Ecuador, where I lived among extreme poverty for 2 years, and it was a transformative event. When I came back to the States, first I was taken aback by the opulence of this country, and then secondly, as I contemplated life and what I would do, I really just felt this burning desire that I wanted to do something that helped a lot of people. I didn't quite know what that was, and wasn't necessarily good at anything. And so I concluded that I would become an entrepreneur and make a whole bunch of money, and then by the age of 30, go out and do something. And the imagination was that if I had money, that I could do something of my choosing, that I wouldn't need to exist in a permission structure where I would need to get the blessing of others to do a given thing.
That seems, I mean, when you were thinking about that, being an entrepreneur wasn't as trendy on every website. I'm just curious how, as someone growing up in Utah and going to Ecuador, how you even knew that that was possible. That's fascinating.
I just did the math. I mean, I looked at the possible career trajectories and saw that most of them were based on a trading time for money kind of scenario. And I knew that I needed to basically figure out how to not sit in that system, but create a different system where I could create value of some unknown variety, and which pointed me towards entrepreneurship. And so really it was trying to maximize this objective of sufficient resources to then do something meaningful.
But no one told you, they had no mentor telling you this, you just worked it out for yourself?
That's right.
Okay. So what did you do to get there?
I started several companies. Some worked, some didn't. The recent company I built, Braintree Venmo, which was acquired, did seed the ability to do Kernel. But it was a long road. I think if I really would have known at 21 when I made that goal what was going to be required, I may have thought twice. It was excruciatingly painful and on a scale that I really could not have imagined.
So you're saying success takes hard work? Is this what you're trying to tell me?
I mean, certainly I stuck at it, but also I was lucky. And once you throw your hat in the ring, some things, of course, are in your control, but most of life is being in the right place at the right time with the right thing. And there's more to one's path than what we can design ourselves. I mean, I like the statement that Mike Tyson says that everyone has a plan until you get punched in the mouth. And that's certainly true. Out of the gate, I was punched and had to just figure things out moment by moment.
What did you learn from the failures that helped you ultimately, do Venmo and Braintree?
It's really about finding the right entry point.
Okay.
And when contemplating what to do, you can analyze several things and chart out those paths, but really, I guess it maps to Kernel, the skill sets that I learned. When I started Kernel, I had no expertise in the field, and that probably was my best attribute, in that I was naive. And so I was willing to go after something that most everyone told me was impossible. And there was nothing here to do. But in doing that, the process we went about doing it is we spent the first 2 years of the company evaluating pretty much everything that we could find in the industry. We read all the scientific papers, we acquired hardware ourselves, did data acquisition, and we analyzed the various paths. And the question we were trying to answer was, is there anything here? And if so, does it have the characteristics to become a breakout industry? If you look at the technology of neuroimaging, there's several different varieties, including EEG on the non-invasive end, and fMRI and squid-based MEG is invasive, DBS. But each one of those technologies sits in its own niche. Mm-hmm. It doesn't have a broader appeal. Yep. And so thinking back to the years of entrepreneurship, it's really about the selection process of finely tuning what you do and why. Because as an entrepreneur, you typically only have 2 or 3 missteps. If you make too many errors, especially in the beginning, it's game over. And so there's a tremendous need for good decision making very early on.
So what made you think about the brain and neuroscience out of everything you could have done?
I'd say it's part personal and part philosophical. Personally, when I was building the companies from age 21 through selling Braintree Venmo, I had chronic depression for a decade. And
very common experience for entrepreneurs, right?
I think so. I think much more common than most people realize. That's right. And it's an existence that I wouldn't wish on anybody. It is, I can't imagine anything more than to be deprived of hope, of
and enjoyment and all the things.
All of it. It's excruciating. And I tried everything known to man, and I couldn't fix it. And it always bothered me that I couldn't actually measure my brain. You know, the ways I tried, electrical stimulation, TDCS and TMS, and I tried talk therapy, and I tried everything. But the one thing I couldn't do was actually, on a regular basis, get access to my brain and understand what's going on. And then I've also, people in my family have suffered from addiction challenges, and so the central nervous system has been a pretty important part of my life, and I've been surrounded by these kinds of problems. The second thing I guess I'd say philosophical is after Braintree Venmo, my idea initially when I was 21 was what good can I do in the world? And so I think it was probably coming from my religious upbringing of wanting to have that disposition of contributing to people's lives. At the age of 35, after selling the company, the question was much different to me. When I surveyed the world, I had left my religion at that time. The question that seemed relevant to me was, how can the human race and all intelligence on this earth survive itself and thrive?
Yep.
And it's not clear to me that we've got this all taken care of. And it's also not clear to me that we've properly sized up the problems we have. And so if you take any given problem in society, anything we are contemplating, including politics, economics, relationships, even with ourselves and others, it all comes back to the brain and the mind, the central nervous system. And we sit in this large contextual network of influences, but really the thing that makes us, we have no access to. And so we can measure everything in the known universe, black holes, our calories, our steps, and the brain and the mind is the only thing we can't, one of the only things we cannot measure. So with those things, it seemed to me that the most relevant thing I could apply my attention and resources to would be trying to build technology that brought the accessibility of the brain and mind and made it as accessible as nutrition or calories or steps.
Were you, as someone you said sort of naive to the area, were you shocked or surprised at all that we weren't able to measure the mind the way we do with everything else?
Our brain is, evolution did a wonderful job of keeping our brain in a safe place outside of danger. And so it's a difficult thing to get access to. And yes, after looking at all the different approaches, I completely understand why the industry has struggled to create breakthrough access. It is an extraordinarily difficult problem.
So you spent, I think, about 4 years just working in stealth, right?
That's right.
So what have you been up to? What have you been building?
So right here is a good example. The objectives we had for building technology is we wanted to cross a threshold of neural data fidelity.
Okay.
And so, for example, EEG is a useful technology. It lacks the quality for it to be broadly used in society. It sits in very niche areas. And fMRI is useful, but you sit in these big machines, the 110 decibel sounds. It's not conducive to large-scale acquisition.
Right.
And so if you think about it from the framework of an effort gap, and you say, Like if we let's just use a couple questions, like how difficult would it be for you and I to get a coffee right now? Not very difficult. We'd have it in our immediate access. If we said, how difficult would it be to understand what our cholesterol levels are? Like there's a process for that. We go to our doctor and we get a requisition and we get the blood draw. If we said, what would it take to get our brain scanned? We're probably 3 weeks away from that.
If you're lucky.
If you're lucky. Yeah. And so that's absurd. That from a simple request of I have some question about my brain or mind, whether it's something I'm exploring or whether I'm concerned about it, it is a multi-week process to get access to. And so the question we had is, could you build technology that basically eliminated that effort gap? And so if I had the question of, I'd like to get insight to my brain for whatever reason, I can do it right now. And this is the technology we've built. And so this is what we call Kernel Flow. Mm-hmm. It's built on a technology called time domain near infrared spectroscopy. So we shine light in, and then photons come back out, and we record those photons, and we get oxygenation and deoxygenation of the brain. And so this is we disassembled this so you could get some insight into it. There's a plate that sit here in the frontal and the back as well. But there's 52 of these modules that tile the head, so you have a full head coverage. Each one of these modules has a source, so a laser with 2 frequencies, and then these are detectors. So they're picking up the photons when they come back. And to give you a data point on the level of improvement that we've made, most state-of-the-art systems today that have a similar technology will collect something like 1,000 photons, or 1 million photons per second. So you pulse a laser in and a few come back. Our system collects upwards to 1 billion on the same time scale, 800 million.
So compared to systems that really fill up a whole room, you have to go to a hospital right?
That's right.
So now you just miniaturized it, it's miniaturized and more powerful.
That's correct. Okay. So in this scenario, every photon that comes back represents information. So we're getting 1,000 times more information than current systems, and like you said, we've made this accessible and low cost relative to what's out there today. And so we think this closes the effort gap, where if you imagine a scenario where a football team at a high school wants to have immediate access to an interface to evaluate anyone's brain at any given moment in case there's a problem, or in an ambulance, or at home, or if you want to modulate, you want to see what's going on when you take a certain medication, whatever the use case is, Kernel Flow would accomplish that. And we think for the first time ever, we believe we can dare imagine having a device in every home by 2033, that it crosses that threshold of value, price, accessibility.
So I'm sure everyone in the audience like me, and we've been talking for quite a while about this, right? The applications are almost limitless. Mm-hmm. So we could spend 3 hours talking about in different industries, etc. But where do you think the applications are that you think about at the moment with this?
It's interesting. We've actually worked very hard inside of Kernel to be aware of our own thinking and how it relates to the technology, because we all superimpose our preferences and our imaginations on the technology.
Yes.
But really, we live within an ecosystem of desired use cases. And so we, of course, we know we can state the obvious ones, but especially for this group working on the central nervous system, is you can imagine that if you had this in a person's home, and you were sampling neural activity multiple times a day, and you were looking at what effects medications had, you were looking at performance characteristics, etc., that would be an absolute game changer in the ability to understand what is actually happening in the mind.
Right, so when you think of any therapeutic area right now, the outcome measures, let's say in a clinical trial, are done every few weeks maybe.
That's right.
Whereas here, it's the equivalent of many people trying to really how do we get at that, what the patient's doing outside the clinic.
That's right.
So you're really providing that within the context of clinical trials, healthcare, beyond healthcare, really access to that information far more than we have data on any person right now, I would imagine, easily. That's
right. I think if I'm not mistaken, the person who has the most recorded hours in history is something like 21 hours in an fMRI machine, and they discontinued it because of tinnitus. It was just too loud and laborious. And so with this device, you can imagine a person logging, hundreds of hours easily. And I think that by doing this, what we're accomplishing, not just with the easy access, but we're bringing the brain and mind into the mainstream of the primary technological thrust of society. So compute power has increased 1 trillion-fold over a few decades. Machine learning and AI are now able to do things with data that we could never do before. And that's not been possible with brain data. We haven't had enough of it.
Yes. And
we haven't had it in the right contextual settings. And we've put people in these big systems and had them be clanking around these loud noises and then ask them to be normal in what they're trying to do. So we haven't pulled the brain and the mind into the main technological abilities we had as society. And that's what Kernel Flow does, is it opens up a new frontier, not only for understanding ourselves, but to achieve the statistical powers and of one and of many that we couldn't imagine before.
And if I understood you correctly earlier, what you're really saying also as the scientist in your company, and I know you have many scientists working here, you're not imposing what you think the use cases are, you're providing this, would you even call it like neuroscience as a service?
That's right. So I mean, I like the story of Thomas Edison when, as an inventor, he sat down and was writing down his ideas on how electricity was going to be used. And I think if I remember this correctly, he wrote recording a sermon was his idea, and listening to music was down to like number 8. And so we are very careful in that we do want to work closely with partners. And we want to explain the system capabilities, imagine certain hypotheses together, and then do it. And it's why we have 50 of these systems that we're going to make available to partners starting in January.
Okay.
And each one, of course, is after a specific objective for what they're trying to achieve, whether it be biomarkers or something else. And we think that the power is going to be millions of these devices in this large community and ecosystem that allows a level of cooperation and insight that doesn't exist today. Most work done in the brain and the mind is really done in these silos.
Yep.
There's not a lot of collaboration, and if you can bring people together with this large-scale data acquisition plus these different perspectives, you can imagine a scenario where the follow-on platform that the world builds on primarily is our brain and our minds. It's not from the smartphone. There's an app for that in what we're doing. And so our mind, our brains become the central focus of the things we scaffold on top of, enabled by this device.
So really, I mean, our summit's called Collaborating for Novel Solutions. So you're really pushing for a gigantic sort of network of collaboration around really a whole new way of being able to access the centrality of the brain.
That's right. And I think a lot of people who've been at this for quite some time have legitimate skepticism. These neuroimaging technologies have been around for some time.
Yeah.
People have made a concerted effort to try to marry up that value creation, what they're trying to do, and it hasn't worked out all that well. And what we think is it's different now that we've achieved the performance thresholds, the cost, the accessibility, and for the first time, you could imagine incorporating the brain and mind into everything one does.
So I know you have a lot of prominent advisors who are in neuroscience, etc. How did you persuade them that tech people coming from the outside might be able to achieve what really was thought impossible? Some big companies, who work on this in medical devices had really not done.
Yeah. If I think back through the experience, what I found is that in speaking to a given person, they would come to the conversation with their expertise, which makes sense. That's how they've built their career and they've become hyper-specialized. And for me, it became a game not of necessarily understanding their expertise, but their blind spots. What couldn't they see?
Yes.
And I had some license of being naive. I could ask silly questions, but it was really, I remember one time we were speaking to this gentleman, an expert in optics, and we posed a few questions around like, what if you had a custom ASIC that could do the following things? How would that change your thinking? And it spun up an entirely new strain of thought on what would be possible. And so what I found is that the silos that have been built up historically have been built according to the grant process, the money coming in, the time span of people being in certain labs, what kind of projects they can take on, but not on the scale of what we've done at Kernel, where we have 86 people, 34 of which have PhDs. We have, I'd say, world-class expertise in over 12 disciplines, and it's been bringing this combination of people together and asked the question of, is something like this possible? And it was a windy path, and we took many wrong turns, and it was not clear that there was anything to do here for a decent amount of time, but we believe we found it.
Now, I know we could talk for hours, but we only have limited time. Is there anything I haven't asked you around the technology or its application that you'd like to talk about before we finish?
The most significant question in my mind is how can we properly size up the consequential nature of a technology like this? If history is a lesson, technology is always underestimated in the beginning, and then it's overhyped, and then it settles in to its regular course. Brain interfaces, neuroimaging, is among the most underappreciated technology in the world. And people are anchored to certain frameworks. So they've seen somebody control a drone, they've seen a quadriplegic move a cursor, they may have tried something in the past on some kind of endeavor with fMRI or something else. And I would say the question I have, the conversation I want to have with others is, things are different now with this. What does that really mean? And how can we construct hypotheses that truly are equal to the potential of the technology? Because the risk is the hypotheses will be anchored in the past, not with these realities. So I'd ask you, I think this is the first time you've highlighted something in neuroscience for quite some time. As you hear this, what goes through your mind?
So through my mind, first of all, it's very exciting because it really opens up areas that we just didn't think we could do, right? That's one. But for me also, it's beyond, our audience is life sciences, scientists, healthcare. I would say that I just see a lot of intersection between those traditional areas one might think of and really the whole society. And so I'm quite excited about a much bigger picture of thinking through all the possible applications here, good or bad, that we have to think about, right, and sort of consider. So I'm excited to see the journey, frankly, and see where Kernel goes with this. And I would say that everyone knows from the audience that they can come and reach us at Summit to be able to reach Kernel to discuss what they might think of, and they can tell us what they want to do with this new technology, which I do believe is going to really change how we look at the brain. So both myself and many people in our audience are very familiar with fMRI as being state-of-the-art, what we're used to. How is this different? Can you talk about that?
We approach that question from a few angles. One is that there's an element of quality of fMRI. How good is the neural signal you're getting? Two, there's a contextual setting in where you acquire the signal. We know you have to sit in the area there, and it's a loud noise, and you're doing these experiments which are not representative of the real world. There's a cost component, there's an access component, and so taken all together, you could score the system and say, how well does this do for the given objectives we had?
Yes.
And what we said is the fMRI-like quality is on point. If we could achieve that via a wearable system, then we could check that box. What if we could also then make it wearable at home, easy, comfortable, do whole head coverage? Now, we are getting the cortex versus the entire brain, so we're not getting deep structures directly, but in the trade-off space of evaluating how can you make the brain and mind broadly accessible. This was the technology that currently has a path for that implementation. If you look at similar technologies that are acquiring oxygenation, deoxygenation, like NIRS, FNIRS, HD dot, they also have a rack of equipment, and it takes half a day for an expert to set it up. And so we also don't require any experts, that a person with no experience could put the interface on their head and start acquiring information about themselves. And so we've taken the approach of reducing every element of friction we can to acquire data that is immediately relevant to that person and to an organization trying to achieve an outcome. And so that we think we've optimized for the right parameters. And I mean, honestly, I think that the kernel flow is the only technology in the world right now that has a path to imagine being in every home. Other technologies will come along in the years to come, but right now, this is the only path, as far as I can see, that has that ability.
At that level, so this is not some consumer-grade gadget. You're actually saying, not only have you miniaturized this without all the equipment, the expertise needed to run it, but actually the data you're getting is actually far superior to current systems that have all those challenges. Am I hearing that correctly?
That's correct, yeah. So if you even compare things off to fMRI and you say, let's compare the spatial and temporal resolution, spatially you're going to have better with fMRI. Temporally, you're sampling at 1 second with fMRI. With us, we're sampling at 200 hertz. And so it's a very different system. And we're approaching this in a way where even if you say, is it accessible for an individual to put it on their head without expertise, without a PhD helping them do it? And then secondarily is if you say, what are the additional layers of access? For example, API access. So my former company, Braintree and Venmo, the question was, how can you, if you and I want to exchange money, how do we enable that in the fastest possible way with the least amount of friction?
Yeah.
We're doing the same thing here. It's like if you want to get access to, and you're the person or you're a developer doing it, that all these tools offer the accessibility and robustness. And so it represents really taking clinical and academic lab neuroscience and bringing it into the mainstream of machine learning and AI and access and APIs and user-friendly. It hits on all those fronts. And we think with that happening in tandem, yeah, that's what creates the reality that this is different in what we've built.
And I can really see people watching this really getting excited about those possibilities, so thank you.
Thank you.
I'll be swinging this around in front of your face.
Sure.
Okay, this is going to come right onto your forehead.
Okay.
Let me make sure there's nothing that's going to poke you yet. And then this will go around the back of your head.
Yeah. So should I take my glasses off, or you think as well?
I think it's okay.
Okay.
We've had glasses before. Yep, just like that.
Oh, very easy.
Yep, very easy. So go back around the side.
Cool.
Okay, this is looking good. How does it feel? Anything
great.
Uncomfortable?
No.
Okay.
Looking great.
Awesome.
Which one are we doing first?
We'll be doing the turtles first.
Okay.
Wilson, do you have?
And right is.
An officer?
Yeah. Right is match.
Oh, you don't have it. Okay.
You can run it from the other.
And right is match, right?
Yes. Yep. Right is match. And we're beginning now.
So Catherine, I've been through the test. That was the easiest fMRI I've ever done. First of all, do I have a brain? If so, is it functioning?
Yes, I'm happy to say yes for both.
that's a relief to know.
Yeah, it always is. And thanks for coming. I think we've realized you were one of the first people from outside of Kernel to actually participate in one of these experiments.
Right, I heard everyone's been internal, so it's an honor for me. Thank you, Bryan, for me being able to do this as an external person.
Yeah. So one of the first things that we're looking at here after we analyze the data is that we'll look at and see if you are doing the task or not. It really helps to understand if we are trying to find out if the brain is active, if the person is actually responding in a way that matches with what we want. So for this is exactly what we see. So we were asking you to press the button when you saw a green leaf and don't press the button when you saw a red flower. So that's exactly what this is telling us here. This has your reaction times and your responses, and we can see your % correct. So we have a pretty good sense that you understood what we were asking you to do and were doing the task.
So I can follow instructions.
Exactly, yeah.
It's not always the case.
Yes. And then our next question is, what kind of brain activation do we see?
Wow, that's quite the graphic. Okay.
Yeah, so this is a map of how the sensors were on your head.
Yes.
Yeah, so this is the left side of your head, that's the right side, and you can see for you there's a big difference. So the dotted lines are when it was go only, and this is our 2-oxy and deoxy. So for the go only condition, you see it's like kind of flat, and then when you were doing the no-go, when you were trying to inhibit your responses, you see that there's this big activation. And for you, it's on the left side right here.
So what you're saying is, how good am I at inhibiting myself doing my impulsive thing to press the space bar, right?
That's right, yeah.
So how good am I at stopping my impulses?
Well, I think you were pretty good. You're better at this task than I am, but it can depend on the day. So one of the reasons that we designed this task, it's part of a bigger study that we have, a pilot study looking at sleep. And so if you don't sleep, it becomes much more difficult to inhibit that response. So our question is, do we see that in the brain? And also, do we see this in the responses? So this is the exact same task that we run on our internal employees in our big study that goes over 45 days. We measure people every other day and look at how natural variability in sleep affects their ability to do this task and also the activity in their brain.
So it could be sleep, it could be coffee, it could be drugs.
Exactly.
It could be anything they're doing. Yep.
We're recording all of these things together. It could be their mood. Exactly. The brain is so complicated, right? And figuring out what's driving brain activity is very complicated.
And you can look at me during the day, in the morning, in the evening. I'm like going into a big hospital and doing all that, right? So the fact that we can assess me all along the day, that's to me really good.
Yeah.
Okay. So I'm gonna be okay with my brain.
I think so. Yeah.
Okay. Great. Anything else we need to talk about, or I passed the test?
I think you passed the test.
Great.
Well
done. Thank you. I appreciate it. Thank you.